welcome to the Deep Dive. Today we're trying to give you a shortcut into one of the most, well, complicated figures in 20th century science, Edward Teller.
Right. Lived from 1908 to 2003.
And most people, they hear his name and they immediately think of the hydrogen bomb. But our sources today suggest there's a much deeper, a more unified principle at work in his career.
Exactly. We're trying to look past the standard biography. We're looking at Teller's entire body of work as this giant laboratory, really.
Laboratory for what, specifically?
It's where the technical problem of phase control, which is just, how to organize matter and energy, collides directly with the political problem of state power. The physics and the ethics become inseparable.
Okay, let's unpack that. Our sources use a very specific toolkit for this, something called motion theory, or SMT.
They do. And the idea is to connect the physics of the absolute smallest things he studied, like, a single molecule.
All the way up to thermonuclear systems.
All the way up. And then you circle back from the physics to the meaning, the ethics of it all. It's what the sources call the hermeneutic circle.
So to do this deep dive, we need a quick map of the language, the MT language.
Right. And for this to work, you sort of have to forget the definitions you learned in school for a minute. In MT, time isn't a river, it's just a rate. It's how often you count ticks on a clock.
Okay. What about fields?
Fields aren't some kind of mysterious goo filling space. They are just motion gradients. Wherever motion changes, that's a field. And mass. Mass is just a system's resistance to being retuned.
Resistance to being retuned. That's a very different way of thinking about it. What's the real payoff of this whole framework?
The payoff is in how it lets us define order and disorder. This is the crucial part. Coherence is just phase order, and entropy is phase disorder.
So you have a universal ledger.
You have a ledger. If you want to increase order, or what we'll call synchronization, delta C, you have to pay a price. And that price is always paid in measurable heat or thermal entropy.
So the big thesis here is that power is engineered synchronization.
Yes. And the bill for that power is always heat. There's no escaping it.
Teller's whole career, then, is at this crossroads of organized motion and massive heat budgets. So let's start small. Let's go to the molecular level with the Jahn Teller effect.
It's a beautiful place to start. The Jahn Teller effect happens in molecules or crystals where you have degenerate electronic states.
Meaning the electrons have a choice of paths, all at the same energy level.
Exactly. They have options. And what happens is the whole structure actually distorts itself. It actively breaks its own perfect symmetry.
Wait, hold on. That sounds completely backward. You think of a crystal, you think of perfect symmetry. Why would a system deliberately break its own ideal form?
It's a sacrifice. It's giving up structural perfection for functional stability. In the MT reading, that degeneracy, those multiple electron paths, that's ambiguous phase.
It's noise.
It's noise in the system. By distorting, by breaking that symmetry, the molecule forces the electrons onto one single clear path. It dramatically raises the synchronization for that electronic state.
So it achieves a stable, clear function, even if it looks a bit distorted. But you said nothing is free. What's the heat bill here?
The heat bill is the distortion itself. The atoms have to physically move, and that work on the lattice. What radiates away is phonons.
Phonons are just heat.
They're just heat. The system buys electronic order, but it pays the ledger instantly in thermal disorder. This was Teller's first lesson, right there in chemistry. Stable function emerges by breaking symmetry on purpose.
And that one lesson scales up to everything else.
Everything.
Okay, so if a tiny crystal has to do that, what happens when we go to the medium scale and we are the ones forcing the change? Let's talk about radiation hydrodynamics, using light as a hammer.
Right. Now we're in the world of high-energy density physics. This is the inside of a star or a weapon. It's where radiation and matter are trading immense amounts of energy and momentum incredibly fast.
I usually think of the light in these systems as just raw heat, but with the MT framework, light is synchronized. How do we know its phase, its organization, is what's really doing the work?
We have to stop thinking of photons as just heat and start seeing them as a phase-synchronized river of motion. When you focus that river into a cavity, a hohlraum, it doesn't just cook the target inside, it pushes it.
So the photons are physically pushing electrons, which then push the matter.
Exactly. And for a tiny critical moment, the interface between that river of light and the matter actually phase locks. It creates a perfectly clean, sharp, converging front. It's that temporary coherence that pushes so efficiently.
So it's not a messy splash. It's a disciplined knock.
It's a disciplined knock, and it has to be, because the system wants to fall apart into turbulence almost immediately. Engineering that perfect pulse, that synchronization, is everything.
How do we ground this? Are there, like, simple rules?
There are. We know the pressure from the radiation itself is tied to its energy density. But the useful pressure, the ablation pressure that actually does the compressing, is related to the intensity of the light divided by the speed of light.
Making the connection very direct.
Very direct. But Teller also knew there were hard limits. Even with the strongest shock wave you can imagine, the amount you can compress something, that ratio hits a ceiling.
Thermodynamic wall.
A wall.
Oh.
And his genius was realizing that to get around those limits, you had to use this phase, coupling light-shaping matter, to channel the energy faster and more cleanly than a simple shock wave ever could.
Which brings us to the largest scale. Synchronization at scale. We're talking about implosion systems. Without getting into classified details, the basic idea is using radiation from a primary source
to compress and heat a secondary one. The MT read on this is that it's staged phase transfer. It's the ultimate act of channeling motion.
So you're taking the messy energy from an explosion.
And you're laundering it. You're turning it into a temporary, clean, synchronized field of radiation that then drives these perfect converging fronts onto the fuel. You're jacking up the synchronization density until a new channel opens.
The nuclear reaction.
The reaction.
Okay, staged phase transfer sounds very elegant, but what does this framing really add? I mean, don't regular shockwave mechanics explain this?
They explain the how. MT adds the why and the cost. It adds a kind of moral sobriety. It tells you that every successful stage relies on a fleeting moment of perfect phase lock, and that perfect order demands an immediate massive payment in heat.
It also highlights that the physics is universal, right? This isn't just about weapons.
Not at all. The exact same principles are used every day in safe civilian lab experiments for fusion research or making X-rays. The physics of synchronization is the same. The weapon is just a choice of scale and intent.
And Teller applied this same discipline to defense systems later in his life. He was a huge advocate for lasers, strategic defense.
Absolutely. I mean, what is a laser? It's coherence in a box. It is the ultimate synchronization machine. The whole challenge of strategic defense is trying to maintain that coherence, that phase alignment, over huge distances.
Through the atmosphere, which, going back to our first example, is a very, very leaky channel.
Extremely leaky. The atmosphere is just a mess of turbulence and motion gradients. It wants to tear that synchronized beam apart instantly. You have to constantly spend more energy using adaptive optics just to fight the disorder and restore the phase.
So from the tiny molecule to the giant laser beam.
The trade is always the same. If you want power, you buy phase and you budget for the heat.
Okay, so we've seen this heat budget across every scale. Let's close the circle now. How do we actually measure this ledger of phase and heat, especially when it's all happening in, billionths of a second?
We use diagnostics that are essentially phase translators. They don't just measure the energy of an event, they measure the order.
Can you give an example?
A streak camera. It's an amazing device. It literally turns time into space on a screen. You can point it at a shock front, and you can see how long that front stays perfectly coherent and phase-locked before it breaks down into turbulence.
So you can actually watch the synchronization fail in real time.
You can watch the bill come due. X-ray backlighters do something similar. They show you density gradients by measuring how the phase of the X-rays is disrupted as they pass through a target.
This makes the whole thing feel much more concrete. And our sources say that MT actually makes predictions we can test in a lab.
It does, which is critical. A theory has to be falsifiable. MT predicts that if you're driving a radiative shock with a laser, there should be a specific point, a power threshold, where the shock front suddenly phase locks and becomes perfectly smooth.
And what would you see then?
You should see an abrupt drop, a kink, in the rate of entropy production. The heat cost should suddenly change its behavior right as perfect order kicks in.
And if it doesn't, if the heat cost just keeps climbing smoothly?
Then the theory, the idea that coherence is a specific, priced commodity, takes a serious hit. The theory is testable.
This brings it all back to Teller and the ethics of it all.
Okay.
His career really shows how mastering this physical phase control translates directly into the largest possible scale of control. State power.
It does.
So what does this MT framework, this focus on the heat budget, add to that political conversation?
It adds sobriety, a necessary sobriety. When anyone, a general, a politician, an engineer, promises you perfect, clean control, especially at a massive scale.
You ask to see the heat budget.
You ask to see the heat budget because if the plan has no heat bill, if there's no accounting for the cost of creating all that order, It isn't physics.
It's a brochure.
It's a brochure. It's a fantasy. It's denying the fundamental cost of organization. Teller's true legacy isn't just the bomb, it's the discipline of synchronization he mastered, and the question of where our ambition for that kind of control should stop.
So we've come full circle. From ambiguous paths in a crystal to using radiation to force order onto matter and ending with a moral accounting. Read narrowly, Teller's in the H-bomb. But read broadly, he's a lesson in structured motion.
Pick a phase, couple it cleanly, hold it just long enough, and always, always count the heat. That's the physics. Everything else, that's our choice.
Thank you for taking us through this, an incredibly deep dive.
My pleasure. And for you, the listener, we'll leave you with this one thought to mull over, a way to look at the world around you. Time is rate, fields are gradients, and power is paid in heat.